All right, so Han Solo once said that the Millennium Falcon made the Kessel Run in less than 12 parsecs. Since 1 parsec equals 3.26 light years, which is the distance that light travels in a year. So it's a distance, it's not a time, even though it says light years. 1 light year equals 5.88 times 10 to the 12th miles, and 1 mile equals 1,600 meters. So let's just assume that all of those, let's just not worry about sig figs in this problem. I know that that's weird, and I shouldn't do that, but we're not going to worry about sig figs in this problem because my answers are a little messed up as it comes to sig figs. So if we were going to worry about sig figs, then the correct starting number for this should be 12.0 since all of our answers have 3 sig figs. But let's keep going. So these equal signs all give us different conversion factors. So one conversion factor is that 1 parsec equals 3.26 light years. Another conversion factor is 1 light year equals 5.88 times 10 to the 12th miles. And our final conversion factor is 1 mile equals 1,600 meters. So now we're going to use those conversion factors to solve the problem. And I'm going to give us some more space on the next slide to solve the problem. But just as a fun aside, what's wrong with this quote? He did the Kessel Run in less than 12 parsecs. That makes it sound like he's doing the Kessel Run in a certain amount of time, but a parsec is actually a distance, which is why we're going to end up in meters. Because you can't convert times to distances, you have to stick distance to distance. So the thing that's wrong with the quote, which you might have heard in some, I don't know, fan videos or something, if you are a Star Wars fan. The problem with the quote is that 12 parsecs is a distance, not a time. So it should have been more like 12 seconds or 12 minutes, not 12 parsecs. Cool. Anyway, let's solve this problem. All right, so we have 12 parsecs. That's what we're starting with. So our first conversion factor is 1 parsec equals 3.26 light years. So our conversion factor is going to be 1 parsec over 3.26 light years. I'm going to call that LY, or 3.26 light years over 1 parsec. And which one we use is going to depend on what we want to cancel out. Remember, so we want to have our given unit cancel out. So the given unit has to be on the bottom. So we want to use this one. So we put 3.26 light years on top and 1 parsec on the bottom. So now our parsecs cancel out and our units are light years. Okay, so next we want to go from light years to miles. So we've got 1 light year equals 5.88 times 10 to the 12th miles. So again, we have that conversion factor. 1 light year is 5.88 times 10 to the 12th miles. But we want light years on the bottom so that it'll cancel out here because it's currently on the top. So we're going to flip-flop it just like we did with light years in parsecs. So 1 light year goes on the bottom, 5.88 times 10 to the 12th miles goes on top. Light years cancel out, and now we're in miles. So we want to do the same thing with miles and meters. So 1 mile equals 1,600 meters. We can write our conversion factor. But again, we want miles on the bottom, so it cancels out. So we're going to flip-flop it. So we're going to put 1 mile on the bottom and 1,600 meters on top. So now miles cancel out, and we end up with meters as our unit. And that's the unit that we want in our answer. So we did it. So now we just have to plug this into our calculator. Okay, so let me erase down here. You can always pause and go back to that part of the video if I went too fast. All right, so when we plug that into our calculator, we're going to do 12 times 3.26 times 5.88, and you should type it in your calculator as E. So use that EE button or the EXP button or the times 10 to the Y button, whatever it looks like on your calculator. You're going to plug that in and it's going to give you a capital E, and then next to the capital E you put a 12 and then times 1,600. So you can plug it all in one step. And when you do that, you're going to end up with, let me plug it in right now with you guys. I plugged it in wrong, so let me plug it in again. There we go. Our answer is 3.68 times 10 to the 17th power. Because remember, I said that we should change it to 12.0 so that my given answers match up with the sig figs in the problem. So, and that is meters. That's our final answer. So that was, let's go back and see which letter answer that should have been. D. Should have been letter D as our answer. Cool. So make sure you stop and pause this and go back and watch it again as many times as you need to understand what's going on. If I'm going too fast, make sure you write it down and try it yourself so that you are familiar with the process and not just monkeying what I do. Okay, make sure you know how to do it yourself. All right. So that was the first problem that was in the lecture slides that I wanted you guys to see. Next was this cheetah question with, letter answers that weren't there before. So a cheetah can run at 65 miles per hour. The average human runs a 100-meter sprint in 14 seconds. With a 600-meter head start, can you get to the tree that is 300 meters away before the cheetah gets to you? All right, it's a pretty fun question, right? I mean, not if this is actually happening to you. If this is actually happening to you, it's terrifying. Anyway, let's see what we get. Do we make it safely to the tree? Does the cheetah get us before we reach the tree? Or let's think about that. Cheetahs can climb trees, so it doesn't matter if you get to the tree first. Yeah, well, that might be the right answer, but we're gonna try and solve it anyway in the spirit of thinking that you will survive. All right, so let's get some room to write. So we've got, let's see all the numbers we've got. 65 miles per hour. And then the human is 100 meters sprint in 14 seconds. And then we've got some other distances here. So our distances are in meters for, we've got two distances in meters and a distance in meters per second, or a rate in meters per second for the human sprinting. So I'm gonna convert this first one into meters. You don't have to. You could convert everything into miles instead. There's several ways to solve a problem. You don't always have to use the same one that I do, but I'm going to go through it for you. So if this cheetah runs 65 miles per hour, let's see how fast that is in meters per second, because we got meters per second with our human. All right, so meters per second. So there is 1,600 meters in 1 mile, which was a conversion factor from our previous problem. So you can go back there and check if you didn't remember this conversion factor. Okay, and there is 1 hour in 3,600 seconds. So that's 60 minutes and 60 seconds per minute, 60 minutes per hour. You multiply them together to get 3,600 seconds per hour. All right, so we canceled out miles, miles on top, miles on the bottom. We canceled out hours, hours on top, hours on the bottom. And what do we get for this? So how fast does our cheetah run in meters per second? So we're going to plug this into the calculator. 65 times 1,600 divided by 3,600. I got 28.88888888889. So we're not going to worry about sig figs yet, but let's see what we get to when we're done. All right, so that's how fast the cheetah runs, meters per second. How fast does the person run? So we've got 100 meters in 14 seconds. So let's find out what that is in meters per second. So let's divide 100 by 14. So that is 7.14286. I'm going to round it there, meters per second. So you can see that the cheetah is probably about 4 times faster than us. So that's not good, but let's keep going. So we have a 600-meter head start. We're going to a tree that is 300 meters away. So let's see how long it takes us to get to that tree. So 300 meters. We want meters to cancel out, and we want to end up with seconds. We want a time. We want to see how long it takes us to get to the tree. So this is our rate of speed. This is how fast we run. So we want meters to be on the bottom. So we can think of this as 7.14286 meters over 1 second. That's what the per second means. So I'm going to write it like that so that we can use it as a conversion factor. So just like our previous problem, I want to flip the conversion factor because we want meters to cancel out. All right. So if you multiply across the top, you just get 300. Our meters cancel out. So then we divide by the bottom. So 300 divided by 7.14286. That's, I'm going to say that's roughly 42 seconds. It takes us 42 seconds to get to the tree. Let's see how fast the cheetah can get to the tree. So note that the cheetah is 600 meters behind you. So the cheetah has to go that 600 meters and 300 meters more to get to the tree. So if the cheetah gets to the tree before we get to the tree, that means the cheetah is going to get to us before we get to the tree. All right, so let's see how long it takes the cheetah to get to the tree. So the cheetah is going 900 meters, 600 plus 300. And this is the cheetah speed. And we're going to say that's over 1 second, and we're going to flip it again, just like we did for the human. So that's going to be 28.888889 meters and 1 second. Meters are going to cancel out. It'll be 900 on top and 28.888888 whatever 9. So let's divide that. 1 900 divided by 28.888889. Ah, okay, so I see that it only takes the cheetah 31.15. It doesn't really matter how many decimal places you go to there because we're not looking for a number answer. We're just looking for a yes or a no. So the cheetah could get to the tree in 31.15 seconds. It takes us 42 seconds to get to the tree. The cheetah's not going to go all the way to the tree if it sees us. It's going to get us before we get to the tree. So that's unfortunate, but even if we didn't consider the fact that cheetahs can climb trees, we're dead either way. Sorry. Good thing it's just a practice problem and not a real life problem, because that would be very, very sad. All right, so if we went back to our answers, that would be no. The cheetah gets you before you reach the tree. So, sad but true. All right, let's see, what else do we have? Those were the two I told you to practice, in addition to practicing some metric conversions with brownie recipes. But I had another one that I wanted to practice just in case. I put this one in as an extra. So you can stop if you think you're good on dimensional analysis, or we can keep seeing some practice problems. All right, I'm a big Harry Potter fan. So during a Gryffindor versus Slytherin Quidditch match, Harry Potter and Draco Malfoy see the snitch at the same time and start racing towards it. Harry is flying at a speed of 20 miles per hour, and Draco is flying at a speed of 600 meters per minute. If they both start from the same distance away, who catches the snitch? All right, cool. So we've got 20 miles per hour and 600 meters per minute. They're going the same distance. They start from the same distance away, so they have to cover the same distance. So we don't have to worry about that. We just have to find out which one's going faster, okay? So it's either 10 points to Gryffindor or Potter stinks. Let's find out which. So it doesn't matter which one you convert. I'm gonna let's convert 600 meters per minute to miles per hour this time, because I have been going from miles to meters for all of our other problems. So this one, I'm gonna do the opposite. So let's convert 600 meters per minute into miles per hour. So 600 meters per minute, so 1 minute. All right, so there are, once again, 1,600 meters in 1 mile. That gets us to our miles. So meters cancel out. And there are 60 minutes in 1 hour. And that gets us to our per hour. So minutes cancel out. We're going to end up with miles over hours, which is what we want. So we multiply across the top, 600 times 60, and divide by the bottom. So 600 times 60 divided by 1,600. And I got 22.5 miles per hour. Is that faster than Harry? Yes. Draco is flying faster than Harry Potter, so Potter stinks. Potter stinks. Draco wins. Cool. All right, so that's one more problem for you. And let's take a look at an example problem from this Metric Brownies recipe conversion, you can stop at any time, pause it, take a break, come back, write down notes, make sure you're trying these problems yourself. I would suggest watching this video, pausing before I solve the problem, trying to solve it yourself, and seeing what you get. I guess it's a little late in the video to tell you that, but if you're going to try it again, if you're going to watch it again, I don't know, at the end of the semester for a review, then you can listen to this advice then. All right, so we're stuck in quarantine for 60 days. If only that was the case. We now know that it's like 365 days, probably, maybe more. But pretend we were only stuck in quarantine for 60 days and we want to eat a brownie every day. How many cups of sugar do we need using this recipe? All right, so we're gonna look at sugar. All right, so this makes 25 large brownies, this recipe. And we need 714 grams of sugar to make 25 brownies. So that's a conversion factor. 714 grams of sugar per 25 brownies. So there's a conversion factor for us. We want to eat one brownie every day for 60 days. So we want 60 brownies. All right, we're most of the way there. We've got 60 brownies and a conversion factor between brownies and grams, but our question asks for cups. So we need the conversion between grams and cups. And here it is. There are some other conversions here for you if you want to just practice going between different units, but these are the ones that we need. Actually, we don't need that one either. All right, so we want 60 brownies. We want to cancel out brownies. So 25 brownies goes on the bottom. And this is our conversion factor, 714 grams of sugar per 25 brownies. All right, so now we're to grams of sugar, and we want to go from grams to cups. So here's our other conversion factor. We want grams to cancel out and cups to be our answer. So cups is going to be on top and grams on the bottom. So 340 grams per 1 cup. Grams cancel out, and we're going to end up with cups of sugar. So plug it into your calculator, multiply across the top, divide across the bottom. 60 times 714 divided by 25 divided by 340. So when you plug this into your calculator, I do it like this. Oops. So it looks like this. So it could be a slash or this little division symbol. When you plug it into your calculator, I would do it that way. If you don't do it that way, make sure you do it like this. Divided by, and then use parentheses, 25 times 340. Because I know you're multiplying across the bottom. You're multiplying 25 and 340 on the bottom and 60 and 714 on top, but you don't want to multiply. You don't want to do dividing and then multiplying because that won't work. Order of operations, that will make you multiply the 340 instead of having it in your denominator. So this is how you want to think about it. And you can plug it in again like this. Or like this. These are your two options to plug it into your calculator correctly. Okay, so when we plug it in, what do we get? I got 5.04 cups of sugar. And if we're going to round to the correct number of significant figures, which I didn't do in the previous problems because they weren't actually asking for numbers, but this one is. So if we round to the correct number of significant figures, 60 brownies only has, well, okay, that's not true. 60 brownies, let me stop myself. 60 brownies is a count. So that would technically have unlimited significant figures. So there's not a real win here for significant figures, but most people don't have measuring cups that can go to a 0.04 cup. So instead, I'm going to round it to 5 and say that your brownies might be a teeny bit less sweet than they could be. But I'm going to go with 5 cups of sugar because we have to think practically sometimes as well as with significant figures. All right, cool. So that would be answer B. All right, those are all the practice problems I have for you guys. Please try them yourself. Please do all of these conversions yourself to practice and let me know if you have any questions.